So I'm rebuilding the battery pack for the Topcon total station, the theodolite. The batteries are contained in the handle that fits on top of the Topcon. They're stuffed inside the handle here. They use old technology, which is the NiCad batteries, which were the rechargeable technology at the time back in the 80s. And when I received the Topcon total station, the batteries were dead and they wouldn't take a charge, and I resurrected them, and they managed to last for a week and a half, and then they totally crapped out on me. And so I'm currently rebuilding the pack. I'm replacing the NiCads with newer technology using the Raytheon Nickel Metal Hydride batteries, these AA batteries. The Topcon battery system has a current capacity of 1800 milliamp hours, and the newer technology, just one of these AA batteries has 2400 milliamp hours, and I'm doubling them up to give me a total capacity of 4800 milliamp hours rather than the 1800. So I'm going to have considerably more on time per recharge using these nickel metal hydride batteries. Now, what I'm doing, this is my electronics area here where I'm working on the batteries, and I have some already built up, the replacements here. You can see where I have the ends soldered together on that particular pack, this particular pack, and then these batteries here, and the same thing with this. And I have one final set that I'm doing right here, and I'm going to film that while I solder these together. I have a couple soldering stations. This is my precision micro tip soldering iron for doing real fine work, and then a little more coarse work with this one. And then of course I have this big brute force one that I'm using for soldering onto the batteries. The batteries effectively sink the heat, so we really got to throw a lot of heat to it quickly to get the solder to flow, to get some wires to attach. If I tried using one of these other irons, what would happen is I'd probably end up destroying the batteries, because they'd be sinking all the heat before I got it hot enough. By the time I got it hot enough to melt the solder, the whole cell would be very hot, would burn your hands. And what we want to do is localize the heat, throw a lot of heat in a small area to melt the solder so it doesn't destroy the cells. So that's what I'll be doing here. I'll be using the big iron, and I'm getting it all ready. I have to first tin the iron, because after sitting heated up, it tends to develop a lot of crud, and I have some soldering paste here I tin the iron with. I have a glob of solder down here that I use the tip to melt, and to keep the tip tinned. If it sits too long, it just develops a lot of crud, and then it won't melt the solder. Okay, so now we're just about ready. So what I'm going to do here now is apply a little heat and get this wire soldered on. And then trim it. And what I use here is a piece of aluminum to hold the wire down after I apply heat, so the wire doesn't move out of place and the aluminum won't stick to the solder. Put a little more flux on here and give it one last blast of heat to flow the solder good. So that's the procedure. So you can see now that the wires are soldered on. So I'll go ahead and build the pack up, and then I'll take a video of the final product before I install it into the Topcon handle. I have the battery pack rebuilt for the Topcon theodolite total station. These are the old batteries, the Nickel-Cadmiums in yellow. And here is the new battery pack that I just built using Nickel Metal Hydride, the newer technology. And those will get now installed into the handle. And if all is done correctly, it should fire up the Topcon. This is a schematic of the battery pack charging circuit that I just kind of sketched out, so I knew what I had. So before we install this into the Topcon, we need to test out the battery pack, the new pack, and see if it's given us the correct voltage. I have HP 6.5 digit digital multimeter here, and we'll use that for looking at the voltage. So we take our test leads and hook it up to the battery, and if all is done well, each of these cells should generate a minimum of 2.5 volts, and we have 1, 2, 3, 4, 5, 6, 7 cells times 1.2 volts. That will give us 8.4. That's what the Topcon uses. So we'll hook this up right here and look at the meter. There we go, 9.18 volts, which is just what we need. Each cell puts out between 1.2 and 1.3, so anything more than 8.4 volts will work for the Topcon. So now we're ready to go. We'll take it back over to the handle and install it. My first attempt at building the battery pack, rebuilding the battery pack, didn't fare so well. I was using these AA nickel metal hydride cells. I was pairing them up, 2 of these per replacement batteries, giving a total of 14. There's 4 in here and 10 there. And though the principle was sound and gave the proper voltages and stuff, it turned out that to really fit comfortably into the handle, the fit was rather tight, and when clamping down on the cover, it'd puncture through the insulation and cause shorts, and batteries would heat up rather fast with the fast discharge. So decided that wasn't a real good way of going. So what I'm doing now is rebuilding using some C-cell rechargeable batteries. And here's the electronics area. I have 3 soldering irons here. This is a fine pencil tipped one for doing real fine work, medium tipped one with higher wattage, more heat, and then of course the big brute here, which gives a lot of heat quickly, which you need to do for batteries. You want to touch the contacts, heat it real fast, and then pull away. If you try using one of these smaller irons, what happens is the whole battery will have to come up to temperature before the solder will melt, and then you have a danger of diminishing the capacity of the battery, damaging the battery, the electrolytes, and all that inside. So what we want to do is put heat to it fast and then pull away. So I'm in the process of putting a contact onto the base of this particular battery here, and I'm going to set this down while I put that one contact on, and you can see how it works here. I'm going to put the contact onto this battery here, and this is the contact here. First thing we need to do is clean the tip a bit. We do that with a moist cloth and dip it into the paste, solder paste. Just apply some heat here, and that's it. And cool it down. So that's the principle right there. So I have a total of 6 of them done over here. We got the little pigtails on them, you can see. So now I'm going to be pairing up the batteries, putting them together to construct the final battery array replacement for the Topcon. So once I get that done, then we'll look at that. Rebuild of the Topcon battery pack is now finished. These are the green Rayovac C cells you see here. There's 7 C cells. There's 2 inside the handle and then 5 outside. There are the old batteries, the old Nickel batteries. These new batteries are Nickel Metal Hydride, which have more capacity for the same volume. So should give us a lot more running time on the Topcon. So the thing to do now is to test to see if we're getting the correct voltages, and I'm going to take it over to the multimeter, and we'll do a little testing. This is a semiconductor parameter analyzer that I'm working on. It's almost finished, and more electronics. Just there's our auto level, and some electronics here, some digital multimeters, the HP 34401s. I have some spectrum analyzers, network analyzers, programmable power supplies, signal sources, and I've got some CPU cards from HP workstations. Here we have an HP 34401 set up, and we'll measure the voltage and see what we have. So we'll get our test leads here, and get it set up. Now if I turn this on and we measure the voltage, we should see at least 8.4 volts. Okay, now I'm going to test each of the battery cells. We should be reading anywhere from 1.2 to 1.4 volts per cell. So we'll go on the first one. You Okay, we got 1.4, so the next one will be double that. Yeah, 2.8, and we add 1.4 to that, should give us 4.2. Here we go. And then I have 2 cells to go in the handle there, so that's another 2.8 on top of the 4.2. So let's see what we get. There we go, 7, and then we add another 1.4 to that, and then add another 1.4 to that for the last battery. What do we get? 9.8. Oops. So everything's, there it is, all 7 cells. So we're getting the correct voltages. So now I can do final assembly on this and hook it up to the Topcon and make sure that it turns on properly and everything is working. The Topcon is now assembled. The battery pack is inside the handle here. There's 7 C cells now, on-off switches there. And now we'll test it out. We'll focus in on the display and throw the power switch and see what happens. Okay, now if I remember right, if you tilt the head it will start reading. Gotta unlock it here. Yeah, there we go. So we zero it, and now if I unlock or if I start adjusting, there's a fine adjustment here. It looks like it's working. I'll zero it once more. Now if I rotate this, let's see here, unlock it. It looks like it's reading horizontal angles. I'm going to test here. This changes it from reading left or right, counterclockwise or clockwise for positive angle measurement. So we'll change it to left, zero it. Whoops. Gotta lock it again. Zero it. Now I'll unlock and rotate. It looks like it's doing the right thing. Rotate about 45. Yeah, it looks like about 45 degrees. Rotate it back to 0. Yeah, that's about right. Back to 0. I'll go 180. Yeah, we're getting 180. Rotate it back to 0. Okay, now I'll lock the head and so no, we're not quite reading vertical yet. It looks like what I've been told, that bubble has to be set pretty doggone close to start getting vertical readings. Let's see. see here. There we go. Now we got the bowl in. Okay, I've got it set here. I guess it looks like as I tilt. Let's see here. So pointed straight up, we get 0 degrees. When it's pointed straight up, now rotate it back to 90 here. Looks like we're getting the right readings, and then if we point down, we should get about 180. Well, the vertical and the horizontal angles seem to be working. So far, so good. So, all we need to do now is get it calibrated, which I will do tomorrow. I'll leave for Minneapolis, take this down to Northwestern Laser and have them look it over for me. So that's it for now. Looks like it's working.